people, welcome. Thanks for being here. This is for lesson 1.5 in our Earth Changing Climate unit of study. Just click this little login, and that should take you right to the lesson at hand. Again, we're going to be really focusing on the gases in the atmosphere. And let's start with the warm up. So, there are correct answers for this. What you did in your last lesson was you read a hole in the Earth's ozone layer. You should be able to answer these two questions based on that reading. I'll let you go ahead and answer that. Pause the video, and then we'll come back to it. So, hopefully, we chose B and we chose C, because those are the answers, friends. Yeah, let's move on. Push that hand in button, and let's go. Interesting that ozone does not affect the temperature, but it can still be extremely harmful by letting in too much ultraviolet radiation. So, for this one, again, you would be normally working with a partner to go through some of these. There are 7 of them down at the bottom. These are just questions here. So, and we're going to look at some graphs and charts and other things, but it's really about analyzing and gathering data. So, this first question has to do with the data that we've gathered since about 1880. We're going to look at data from methane, carbon dioxide, sulfur dioxide as we look at these warming temperatures. So first question, which time period's data would provide the best evidence? 1880 to 2014, 95 to 2014, or 2013 to 2014? So again, I hope we've learned that the bigger the data set, the better, and we can analyze and predict, see trends better if we are using a larger data set. So moving on, global temperature. Let's see, we're looking at a chart. Looks like we're seeing a trend. It's steadily going up. Okay, what's this question say? For global average temperature, what is the trend or change? Warmer. Okay, compare the trends for carbon dioxide and temperature in the graphs. Do these graphs show the same trend? So what it's asking is, are we seeing a similar pattern in increase or decrease, or staying the same? And again, especially with our temperature, we've had a lot of fluctuations, and even some little ones with carbon dioxide. But I would say, yeah, as we've increased carbon dioxide, it's also matched our temperature increase. So we would say, yeah, those trends do align. Then do the same thing for methane in temperature. See that little line going up, and if we were to just take the average of all these peaks and troughs, we can see that that's going up as well. So yeah, we see a trend there. Compare the trends for sulfur dioxide and temperature in the graphs below. Do these graphs show the same trend? So we see it's kind of all over the place. We see a sharp decrease, especially towards the end, but we're seeing an increase. So we would say, no, those trends are not showing the same trend. Showing a little bit of an inverse, actually. Which of the following claims do you think might be supported by the graph evidence? You may choose more than one. Let's look at the graph. Oh, wait, the graph evidence are all the ones we just looked at. Okay, I'll figure it out with you guys. How about that? So increased carbon dioxide is causing an increase, causing temperature to increase and ice to decrease. Yeah. Increasing methane is causing temperature to increase and ice to decrease. Yep. Decreasing sulfur dioxide is causing temperature to increase and ice to decrease. No, we did not see that. So let's go to number 7. Number 7 is no question. It's just two of our vocabularies. Carbon dioxide is a molecule made of carbon and oxygen atoms. Yeah, that's such a kindergarten explanation. Carbon dioxide is 1 carbon, and because we have the dioxide, di means 2, so it's 1 carbon, two oxygens bound to it. Methane is a molecule made of carbon and hydrogen atoms. Yes, indeed. So let's go to our modeling tool for part 3 here. So again, we're focusing on why is the ice on the Earth's surface decreasing and temperatures increasing. We're going to use a new modeling tool to show one idea of what could be causing that. So again, previously in part 2 here, we were just learning about the increase in methane and carbon dioxide can increase the Earth's temperature. So that's your job. So what we're going to do, you click this little link, and it's going to take you to this modeling tool. Now, the modeling tool here is not fully activated. So, like, I can't take my temperatures and drag. I'm clicking and dragging, but nothing's happening. But look, I can take gases, and I can click those and drag those over, and I can drop them off somewhere. And if I don't like those gases, I can click on them, drag them away. But my mission here is to show one idea of what could be causing the ice to melt and temperatures to increase. So we have kind of a warm temperature here and then a hot temperature. And again, I can't edit that for this particular model. I also can't change my ice, can't drag my ice. But I can do my gases. So show one idea of what is causing ice to melt. So I'm just going to pick cow farms, methane. And so what we see here is we have our medium temperature with a medium amount of methane. We've got our hot temperature over here, so now I'm going to increase the methane over here. And I can even take my energy absorbed. We've got a medium amount of energy absorbed here, and then we've got a large amount of energy absorbed here. So this is one example. I used methane. You could have also used carbon dioxide for this. Again, nitrogen dioxide wouldn't do anything, so we shouldn't use that. And let's see here. I think you need to take a screen. Yep. Go ahead and take a screenshot of whatever model that you did here, and then in your own words, explain what that model shows. For part 2, you're skipping that. It says do it again, create a second model. It shows a different idea. Just skip it. I think you guys got it now. Let's go to our homework section. This is like the awesomest part of the whole lesson. Basically, you get to destroy the planet, and you want to turn the Earth into a big icy snowball. You're going to use the sim to do that. So when you're in the, that's the sim right there. Got my sim up. So we know that nitrogen dioxide doesn't really affect temperature, but we know sulfur dioxide, methane, carbon do, right? So we're trying to make things cold. So we're going to dial back this carbon dioxide. We're going to dial back this methane. And this sulfur dioxide, remember, the more sulfur dioxide we have in the atmosphere, the more of the sun's rays get reflected back into outer space. So we don't get as warm. So I want to crank that up. And actually, before I do that, friends, I'm going to put it all back to the way it was. Just reset. Yes. Because I do want to see the chart, because I think that's fun. So I'm going to let this run for a little bit on super speed. And then, let's see if I can find my mouse. Can't find my mouse. Oh, there it is. I found it. Hooray for me. So now I'm going to do those things. I'm going to crank down methane, carbon dioxide, crank up sulfur dioxide, and then go. Oh, look at that ice form down along the bottom there. And let's pause that and see what our chart looks like. Okay. So we had kind of steady energy, steady temperature, steady ice. When I made those changes, we went up to 90% surface ice down to 5 degrees centigrade. And 5 degrees centigrade or Celsius is minus 15 degrees. That's our new global temperature. Nice job, friends. You've totally destroyed the Earth by making it way too cold for us to live. I think we need to take a screenshot. Yeah, take a screenshot of that. How did you make it happen? What gases did you use? When you succeeded, describe what happened with the energy absorbed by the surface. So you can look at your chart, see energy absorbed, you can see it, and then that little yellow line is going bye bye. All right, friends. Let's see. I think that's it because for your homework for part 5 over here, we're skipping that part and rolling right into the quiz. All right, friends. Thanks for watching. Don't forget to like, share, comment, and subscribe. I'll see you next time.